Well, hello everyone. I'm Bill Brenner, VP of Custom Content here at CyberRisk Alliance, and I want to welcome you to this SE Media production sponsored by ThreatX. Joining me today is the co-founder and chief strategy officer of ThreatX, Bret. Our topic for today is API protection, minding the gap that probably exists in your web application security program. Before we begin, a few housekeeping notes. First is if you have a question, just select that blue Q&A button down below, and I will keep my eye out for those questions and break in to take them as I see them. If you'd like a copy of our CyberRisk Alliance ThreatX ebook on API protection as the new frontier, you can find that in the handouts button below. And what Bret and I are about to discuss is based in large part on what is in that ebook. Also note that a recording of this session will be made available online after the event. And having said all that, let's begin. Hi, Bret.
How you doing, Bill? Great to be here.
Doing great. So let me just start right out of the gate. Protecting APIs is very, very hard. Talk about why that is.
Yeah, I think APIs have been around for a long time, but obviously we're seeing an explosion in terms of the overall adoption and utilization of APIs, and part of that is because they're the building blocks of the modern applications. And a key element there is reusability and the fact that you can make data and services available to your web applications, other services, your mobile compliance. And there's a lot of power in having that ability to expose APIs more broadly, a lot of reuse that's available. At the same time, that opened up a lot of different vectors, both from an attack surface area and the ability for hackers to come in and use different approaches and different attack vectors, but also just understanding how those services are being used. And I think from a development standpoint, you can make an API extremely powerful, providing a lot of great information, but sometimes that information can be accessed by the wrong hands. And so the ability to really monitor the usage and utilization of those APIs, how they're being accessed, what kind of information they're providing, can become very, very complicated depending on who the user is that's the client is that's attempting to access that information. And so you end up with difficulties using some of the legacy tools maybe that were out there that were more simple static signatures or simple rules based solutions in an attempt to try to provide protection. And you now need things that are more context aware, that have a lot more visibility into how those IPOs are supposed to be used.
Yeah. So API gateway versus, and I'm going to phonetically say the acronym soup, SAST, DAST, SCA versus API protection versus WAF. Uh, Give me a compare and contrast, because I think a lot of confusion tends to reign over these and
Yeah.
getting them
Well,
straight and in their proper compartments.
sure, sure. And again, I think any good security professional will tell you security in layers is typically the best approach. And while we can't all afford to utilize each and every, tool set that's out there, there's certainly, certain tools that are fit for certain purposes. And so when I think of things like the testing tools, the pre-production, SaaS, DAST, and SCA type of tools, very important because the best defense you can have is the ability to actually identify the vulnerabilities and identify, potential pitfalls in your deployment of the APIs before they make it to production. Having said that, obviously, it's very difficult to test for certain conditions, just simply because the normal behavior for one particular user may not be normal for another user. And so it's a great component of your overall architecture, but it's not necessarily enough because you still need to be monitoring the live traffic as it flows through. I think with API gateways, fantastic tool set. Really having a tool set that's kind of the control plane and the ability for you to manage kind of the development and then the utilization of those tool sets. I think API gateways are very strong with authentication, authorization. They can also provide rate limiting. I think, in some cases, though, where they start to fall a little bit short is just in their ability to, deploy complex blocking rules. It's not necessarily core to the platforms that are out there. I think when you look at traditional WAF solutions, web application firewalls, and other application security products that have been around for a while, again, most of those were developed around static signatures and static rules. And so they were able to look at an individual request and try to match that against maybe a known suspicious pattern. But in terms of looking at the complexity that especially APIs bring, where what may be normal behavior in one incident is totally malicious behavior in another incident, you need something that's much more context aware. And so you need the ability to look at transactions over a much longer period of time. You need to understand kind of what does normal traffic look like. You need to be able to identify multiple indicators of potential suspicious behavior, and ideally be able to look at that in a more holistic viewpoint where you can assess the appropriate risk and the appropriate response based on looking at a lot more information and a lot more context. And I think that's really where, if you look at some of the new entrants in the API security space, a lot of those are really approaching it with AI and ML and context-based capabilities that they're bringing to the forefront. One of the challenges that we see, though, is a lot of them are approaching it from an offline perspective, meaning that they are actually pulling the data kind of offline, going through the machinations and the correlation and a lot of the effort to be able to detect these subtleties that are indicators of suspicious behavior, and then ultimately identify potential IPs that need to be blocked. That's great. I think one of the challenges, though, when you're looking at it from that perspective, is much like SIM solutions of the past, those correlations often occur after the fact. Or if they are, occurring and providing integrations to attempt to provide some level of blocking capability, then the challenge is sometimes the best they can do is say block this IP. And that becomes a challenge when we're talking about bot level or DDoS level attacks with thousands of IPs. So it's a complicated, environment out there, and there certainly is a place for each of these approaches and these disciplines and where they fit, but it can be very confusing, I think, for the customers in the market as well.
So we have our first question from the audience.
Great.
Do API management systems provide much protection?
Depends on your definition of what an API management solution is. I mean, I think one of the terms that you'll hear kind of bandied around is API discovery and the ability to identify the APIs, the endpoints, the methods, the parameters, the characteristics basically of the APIs and how they're being utilized. And while that's a great component of an overall solution, being able to compare what's being observed or what's being discovered against what was actually intended for those APIs is one of the key strategies to identifying both, potential attacks, but also potential vulnerabilities in your solution. So I think the API management solutions, again, when I think of API management, oftentimes I lean towards gateway solutions. And I think about the fact that absolutely they are invoking a discipline in the development process to be able to define and specify usage to manage kind of the CI/CD pipeline of how it's being deployed, and then having the ability to take that set of information and then another capability, which is the ability to actually compare what you're seeing in production versus what was originally specified, is a great holistic solution. Unfortunately, a lot of the current management solutions out there, they do a great job on the management side. They don't necessarily have great discovery and comparisons against what was specified versus what they're seeing in production.
Mhm. Thank you for that question to our friend in the audience. Next question of my own. Um, talk. Let's talk for a few minutes about rogue and zombie APIs. What they
Sure.
are, how they happen, and most importantly, how you protect them.
Great. Yeah, I think there's a lot of different terminology out there, whether it's rogue, whether it's zombie, whether it's shadow, a lot of different terminology. When I think of these terms, typically from a zombie API, it's typically an API that's been created. It once had a useful life. It's most likely exposed externally, but through the evolution of the applications or the API stacks, it no longer is being managed and cared for from a development perspective. It's likely not in any kind of schema or specification that's out there, and so it represents a potential risk to your organization just simply because it's almost a forgotten child. It's sitting out there, it's exposed externally. It's something that someone from an attack posture perspective could utilize as part of their reconnaissance or even attack vector, but it's not necessarily something that people are paying attention to on an ongoing basis and ensuring that it's constantly being well tended to.
Mhm.
When I think of zombie APIs, what I think about is, hey, it's an active API, but again, in this case, it's probably not been specified, and therefore, a developer has created it and it's been made available and externally available, but because it's lacking kind of the traditional data classification and security assessment around it, then you have an exposed component out there that's actively being utilized, but again, without the appropriate security measures. And it includes not just the APIs, or endpoints that are being called, but it also includes potentially, methods that weren't originally specified to be used by that API, or potentially different parameters that are being utilized. So it's really the rogue use of an endpoint is almost another characteristic or character for that. I think this is where, kind of combining some of the previous question and some of this, topic, having that ability again to provide visibility to what is your specification. And again, in most cases, we're talking about open API schemas or specifications or Swagger schemas, and there's other names for them, but the ability to define what your expectation for the usage is for these API endpoints, and then the observability component, which allows you to look at, but how is it actually being executed? How do we find those differences? And then how do we determine how best to respond? Whether that's making changes on the development side to shore up so that, they can't make the rogue calls or they can't pass in parameters, or whether it's, providing PII when it shouldn't be. Maybe it's over disclosing too much information. There's a lot of different characteristics that you want to be able to compare and contrast against.
Mhm. Now, talk a, talk a bit, if you can, about some best practices when it comes to assessing and enforcing API schema compliance.
Yeah. Schema compliance to me is a lot of what we've talked about here in a few of these questions here. But when we talk with customers, and each customer is unique, each customer is different, but it feels like a lot of folks are on kind of the continuum, meaning that some folks, the conversation really revolves around the fact that they've got multiple gateways. They've got, multiple technology teams that are exposing APIs, some with a gateway, some without a gateway. And so their first and foremost problem is just they don't know how many APIs they have, and they don't really know, as much information as they should around those APIs. So again, a good first step is to have some form of API discovery tool set out there so that you can get a good sense of what are the actual calls being made, to your application environments or to your servers, and how many APIs are actually sitting out there. How are they being utilized? What are the methods and calls and data components that are being exposed here? And whether you have a schema or you don't have a schema to compare against, it's still a great first step just to get a good picture of what is that overall exposed area that you have. I think from a good second step is obviously the ability to either ingest schema that the application teams are creating. Again, some of the questions we get from our customers are, "Hey, that's great, and I wish our application teams were, always on top of their game. But you've discovered a lot of APIs for which, hey, we don't have a schema defined. How can we deal with that?" So I think having a solution or a capability to be able to take the results of what's being observed go through and understand it to the point where you can then identify and potentially build what I loosely call a pseudo schema, which is, hey, I understand these APIs. This is how they should be utilized. These are the appropriate methods that they should be supporting. These are the appropriate data components that they should be supporting. So I think kind of going at it and taking that approach is certainly one of the first and key components to really understanding what your overall risk looks like. I think from there, it really gets into the runtime aspects. And so I think, certainly a lot of WAF solutions have been around for a long time. They've been providing, some capabilities to protect APIs because at the end of the day, the APIs are, HTTP calls that are going, at a host name. And therefore, they can provide, again, certain capabilities. Where I see the continuum of sophistication in the solutions really comes down to, is it just a static signature engine? Is it looking just at a single request and making a binary decision? Or is it a solution that is, hopefully monitoring the behavior of each of the users of the application and starting to build a risk profile based on, the unique or the suspicious indicators they're seeing, so that you can start to see those patterns and those fingerprints around how the attackers are approaching the applications and the APIs, what techniques are they using, and then how best can you ensure that the APIs are hardened against such attacks, as well as you have the complexity built into your runtime solution to handle some of these complex kind of correlations that are required to actually
Mm-hmm.
invoke the blocking. And then I think, again, we talked a little bit about both the API management side of the house, very important. And then we've talked a lot about, or a little about the testing component. But if you start to bring these things together where, okay, we now understand, the catalog aspect or the inventory aspect of all of the APIs that we have, we understand how best we want them to be utilized. We also understand the types of attacks and the techniques that are being used and the complexity that's involved. That then can now inform you as it relates to how you go about building the test program and the types of testing that you really need to make sure that you're hardening those APIs against. Because the hardest part for me about, pre-production testing has always been, yeah, I can test against the basic vulnerabilities that are out there. But in terms of really understanding the complexity of how each and every one of these, APIs is being utilized by different users with different methods, with different data elements, building a test program against that is pretty complex without fully understanding the normal utilization of those applications versus where the weak spots may be. So,
Mm-hmm. So we have another question from the audience.
great.
And the question is about whether scanning an API specification file, so an HAR file, is
Yep.
sufficient in your view.
No, I would say that it's good, but not fully sufficient when it comes to the protection, because again, the element that I think we're describing here is that so often, the attacks look like normal users. They even look like normal utilization of the APIs, and so the HAR file has a lot of that key information in it, but it's not, it's necessary but not sufficient when it comes to truly understanding kind of that utilization. And we're talking about not just anomalies that you're trying to detect, but it's true indicators of suspicious behavior. And in a lot of these cases, the attackers are obviously, they're financially motivated. They're very, very good. So they know the evasion techniques. They know how to distribute the load across multiple IPs. They know how to, diffuse that attack vector, or maybe they're going to do it at a, DDoS scale where they're launching it with tens of thousands of IPs. And so having a solution that can kind of correlate across these behaviors. And when I talk about correlation, and what I'm talking about is certain indicators of suspicious behavior that you're tying back to the
Mm-hmm.
actual attackers themselves, as well as identifying what they're targeting and the techniques they're using. When you have those two angles combined with what's been defined, that's really where you're going to be able to see kind of that white space. And that allows you to either have the appropriate response schemes in place or certainly have enough information to do a further level of kind of digging into it. And the
Mm-hmm.
last thing I'll say on this is, again, the reason I'm kind of harping on this more holistic and kind of, collective approach is because as they go through the evasion, they can oftentimes maybe overcome one of your detection capabilities. But if you have a proper solution, you're going to be picking up other indicators of suspicious behavior. And even as they are able to evade one component, it's that combined view, that contextual view that you have that really allows you to say, okay, this may look normal, but when combined with these other steps, it's certainly something that I either can build a protection scheme or policy against, or at a minimum, I can do the detailed kind of threat hunting analysis and then ultimately make a response decision around. So again, it's a cat and mouse game, right? It's
Yeah.
always changing. It's whack-a-mole, whatever colloquialism that you want to use. The more information you have, the broader the picture that you have to look at it, the more successful I think you're going to be.
So talk about what other API protection platforms are not getting right. So when we're
Yeah,
talking pure API, um,
yeah. I mean, okay. So let's kind of maybe zero in on.
start with what they're not getting right, and we can pivot
Yeah,
from there to the better way.
yeah, and some of it is kind of defining it. I mean, I think a lot of the new entrants in the market are looking at it from the right perspective in many different ways. So I see almost everyone is really got some notion of an API inventory, an API catalog, an API, assessment engine where they're able to take the transactional flow, look through the transactions, start to build out the inventory of all of the endpoints, and again, how they're being utilized, and looking for those, potential opportunities where they can see either attack indicators or they can see vulnerability indicators. That's great, and I think everybody should be, doing that as part of their solution. A lot of the new entrants are also adding some form of testing, whether that's an integration to an existing test platform or whether it's a proprietary test platform. But I think, having the ability to say this is what we're seeing, and then integrating that data into your test platform to make sure that you can test against it, very, very important. Where I see the biggest differences, kind of really does lie in the how do you handle the runtime aspect of it. And so for a lot of these solutions, when you're talking about taking, the data, you're pulling it offline so that you can do a larger kind of data analytics process. Very smart, very good. And I think, there's a lot of power in that approach, and it gives you the ability to, correlate across a lot of different data elements and ultimately identify how they made the attack. Where I see some of the failures in that approach, though, are they've now got this very complicated, set of correlations that they needed to actually identify this particular attack. And then the recommendation is, okay, now stick this in a WAF or stick this in a gateway, which in most cases, they don't have that same sophistication or capability. And if they were able to detect this particular pattern over a number of steps that were involved in that attack, the best they're going to be able to do is say, okay, well, I know the IP of that particular attack vector, so just block the IP. But they weren't able to actually build the complexity of the multiple steps and the indicators that they're looking for into a static signature engine that's only looking at one request at a time. And I think that's really where, the difference that I see is, you I applaud the contextual view because it's something that I think we started out doing 7 years ago with our platform, and it's been a challenge to really find that right line between what are the key indicators that you need to be looking at, how can you process them in a fast and efficient way, and still remain in line so that you can have the same, techniques that you're using to correlate and detect this behavior also trigger your blocking and trigger it not just at a single IP, but trigger it at the behavior that you're seeing. And that's the biggest challenge because you can do a lot of things when you're offline because you can chew up a lot of processing power. But when you're trying to do something like that inline, you're not going to get the response times that you need, from the application or for the performance that you need. And that's kind of the balancing act that I think that we're looking at here.
So I have a two-part question from somebody in the audience.
Okay.
Uh, let's start with the first part, and then I'll go into the second. Can you give a simple example of how a REST API request can be used maliciously on a simple password protected API method.
A simple example on a RESTful API, great. On a password protected method. I mean, to me, that really depends on what kind of authentication you have for that particular method as it relates to once you've authenticated the user, is that method still exposing other capabilities or other data components once the user's been authenticated? And this really gets into the object level authentication or function level authentication that you see in the OWASP top 10. It's one step to actually get authenticated into the solution, and then once you're authenticated, you can make the calls that you need to make against the particular endpoints. But unless you're really authenticating the types of methods and the types of data that are being observed there, you still run the risk of somebody logging in, getting authenticated. And again, the classic examples are I'm logged in as Bret, and I can look at Bret's balances or I can look at Bret's, PII. But can I also then, as a hacker, make a simple change and say, okay, now I want to look at bills, or I want to, enumerate the ID so I can start to look at other users because the security or authentication has not been established deep enough in the actual endpoints and services. So I'm not sure that was fully answering the question the way they intended, but
Well, let me get to the second piece of it because I think that'll
yep.
pull this all together. So the other part of the question was, does Microsoft's implementation of API controller slash actions provide any sort of anti-fraud measures built into it?
Well, I'm not going to claim to be a complete expert on the latest and greatest of where Microsoft is at. I would say anything you can do from an API management perspective to assist with building in the authentication as well as the authorization that's required deeper in the stack, deeper in the service calls to ensure that the user is the user that they say they are, and that the data that they're accessing is the data that they should be available to access, is a huge win for any of these types of solutions. I would say that's again a really great start. It's again, there's a lot of other types of attacks, and so the authentication and authorization is a key component to really solidifying your security components, but it obviously isn't going to be enough, depending on the type of attacks that we're seeing. In a simple example would be credential stuffing, and the fact that if someone is coming in and they've got legitimate credentials, um, how do you know that the person that logged in really has the appropriate credentials or not? What are you using to maybe fingerprint the actual client that's coming in to determine that, hey, there's an anomaly there because that client first said they were Bret. Now they're coming right back and saying that they're Bill. And now they're coming right back and saying that they're Mary and Susie and so on and so forth. So you still have to have other aspects that you're looking for as it relates to these indicators of suspicious behavior that allow you to do, a more complete job. And, maybe to bounce back between this question and maybe the prior topic that we were on, the challenge with an offline solution can be they don't have the ability to actually do the IP interrogation, to actually do the IP fingerprinting, to be able to look at key elements of the actual attackers and be able to say, okay, even if they're coming from multiple IPs, these guys share a lot of the same characteristics, whether it's a TLS fingerprint, whether it's certain ciphers, whether it's other elements, and combine that with the behaviors that you're seeing them utilize to be able to say, okay, they say that they're this person, but the reality is I need to correlate the behavior across each of these different users or what we would call entities back to a single attacker. So I drifted on your question there a little bit, but I think it's, again, love authentication and authorization because that really does help harden and tighten down the APIs, but it's not, there still are plenty of attack vectors these guys are using.
Now, I think you covered the bases. So I'm going to now make a couple of statements that I've seen as we've gotten to know ThreatX and work with you. And I'll want what I'm going to do is I will say it and then ask that you expand on it, kind of go into the meaning. The first one is, if you're not blocking, you're not protecting. So seemingly simple statement, but what is ThreatX mean
Well, again,
specifically?
I think when we compete against traditional WAF or WAP, which is web application and API platforms that
Mm-hmm.
are out there, they're blocking. And so, you can debate how good the protection is, but whatever they're detecting, they have the ability to block it. And so that's key in core. I think as we look at some of the new entrants to the market, and again, things will change and they will evolve, but a lot of these solutions that are calling themselves API protection solutions are not in line, they're offline. And
Mm-hmm.
again, so they have very robust, analytics and machine learning and capabilities to look at all these different correlation points and pull things together. But at the end of the day, when you read the fine print, they say, and now you can take this information and you can plug it back into your existing WAF solution. And so, I guess it's semantics to a certain degree. But again, we talked through the challenge before. If you're good at detection, but you don't have the ability to block inherent in your solution, then at best, you're a step behind the attackers. And at worst, you found a very complicated attack pattern that you're asking a very simple solution to try to build a rule that can encapsulate all those different steps and components. And it becomes very, very difficult. And then, that's in the base scenarios. Now let's take it up a notch for what we see in the account takeover or credential stuffing attacks where, it's not a single IP. It's tens of thousands of IPs. It's hundreds of thousands of IPs. And they're distributing the load across those. And so it becomes that much more difficult then to say, how are you going to protect against that? You can block them after the fact, but were you able to detect them fast enough and then create the policies that would actually provide the blocking and protection in time? And that's kind of the trade-off and the challenge when you're an offline solution.
So statement number 2, location, location, location. From where we sit, we see everything.
Yeah,
So
great marketing
talk.
slogan, right? I love marketing, architecture even. But I think again, it gets into the aspects of the way that we're deployed is basically as a simple reverse proxy container, and so that does give us the ability to be deployed all the way at the edge, where we're kind of the external barrier, and we're going to see all inbound traffic. We'll process it, cleanse it, and then we can send the clean traffic to whatever backend or origins that are required. At the same time, it's a simple Docker container. And so that container can be deployed, all the way down at the microservice level as a, sidecar pattern, or it can be deployed on the ingress for API gateways. A lot of flexibility to deploy it virtually anywhere up and down the stack for both north-south traffic as well as kind of the internal or east-west traffic that's going on. And by being located or having the flexibility to locate in each of these different areas gives us the visibility that we need to not only be able to correlate across a bunch of different points, but again, it's in line. So it gives you the ability to block and block based on as complex a situation of correlation rules as you need to be able to come up with. So I think the location is, still referring to if you're in line, you have a much better, capability to be able to block what you detect. When you're not in line, then you've got just another, complex integration that's really going to be required for these more complex attacks. So
Yep. So I have heard it said that API attacks are going to become the number one attack vector. Um, are we there?
yeah, it's
Because
kind
for
of
me, I
hard.
feel like we are.
I was going to say, yeah, are going to become. I think I saw a Gartner, quote on by 2023 or 2024, and I'm thinking, wow, it feels like we're already there because again, API attacks have been going on. We're a 7, almost 8 year old company now, but we've been protecting APIs for the entirety of our lifespan here, and especially when you look at like I said, account takeover and credential stuffing have been just terrible over the last couple of years. And by and large, where they're loading up is not on the applications where they may have, some of the key capabilities. It's identifying the APIs on the back end and then attempting to kind of bypass traditional security methods and really hammer those APIs. And so, when we look at, our attack, percentages, I mean, it's already in the 60 to 70% of the things that we're detecting are at the API level. And again, no, no, no real astounding sentiment there. I mean, with mobile, especially driving a lot of the API adoption in the early days, and now with more and more of these companies, starting to kind of demand utilization of their APIs in order to do business with them, it's just grown so quickly that I think it's a foregone conclusion that it's the number one attack vector.
Mm-hmm. Yeah, I've also heard it described as the hot new endpoints and treating them as the endpoints that they are.
Yeah. Well, I would say, maybe the next step or the next evolution is really, we talk about APIs, and again, API is a term that's been around forever, going back to the EDI days practically, right? But um, with microservices are just kind of the next launching point, right? I mean, you're getting more and more finite in terms of your ability to encapsulate data and, functionality. And so, you just kind of look at where this is going. There's so much reuse and so much automation being utilized out there that it truly is, it's the fastest growing and the hottest area for us. And again, not to belabor the point, but it's a lot easier to start targeting the APIs because, there's not as many eyes on them. And
Mm-hmm.
especially because the security lacked behind technology adoption, which always happens. But with APIs, they can be accessed a lot more discreetly than maybe the applications could in the past. It was fairly easy to say, okay, we see an application or we see a user, they're coming in over the internet, trying to access the application. We've got kind of a very nice funneling point so that we can deploy our security solutions. APIs, I mean, they're distributed all over the place. They're being accessed by so many different clients and even other APIs or services that, having clear understanding of who's really supposed to be interacting with this API and what is normal versus what is not normal, it's so hard for so many people to be able to, have that visibility and provide that protection that if you're a hacker, where are you going to focus? You're obviously going to focus there because it's the least well understood and least well protected area, and it's a lot easier to fly under the radar when you're looking at, focusing on the APIs themselves.
Yeah. So let's talk about that API attack surface. And when it comes to how to understand which APIs present the most risk to your
Yeah.
organization, what are some of the red flags you would advise folks to watch
Well,
for?
there's a lot of different aspects that you want to watch for, but I think even going back to the early part of this conversation is being able to observe those APIs, being able to understand how they're being utilized is very key to being able to have the kind of metrics and the optics that you need. So, you can go through the OWASP top 10 list and you can look at things like broken object level authentication, user authentication, or authentication. You can look at, security misconfigurations. There's just so many different angles. A lot of them are very similar, or many of them are kind of similar to what we saw with web applications, things like SQL injections or, improper asset management. When you look at all these different angles that are out there, though, again, it really still boils back down to how were those utilized, how are those applications, supposed to be utilized? How did you specify which endpoints and how they should be, invoked? What type of data they should be utilizing, and then how are you actually monitoring the actual transactional data there, execution of those, and then how are you pulling those two things together so that you have that level of visibility? So I think, again, that's why that is one of the key pillars, I think, of a sound security strategy is having an API catalog or an API inventory and being able to assess, is this normal usage or not, and then how do you start to build in the key policies as well as the detection components to be able to look for any kind of indicator of suspicious behavior.
Yep. Do ThreatX solutions require cloud services, or can it be exclusively on-prem?
Yeah, so I think going back to the way I kind of positioned it earlier, it is a Docker container-based solution. So, I haven't looked at the statistics recently, but it's typically in the 65 to 70% of the applications and API environments that we protect actually utilize a hosted environment that ThreatX provides. And the reason they're doing that is it's kind of the easiest button for them. They can basically take the host names, they can do a DNS redirect of some sort, route the traffic to us. We're going to see every call made, and therefore we can provide the protection. We'll manage the platform aspects of it. We'll actually do kind of a more cohesive policy management. And one of the aspects that you always get, whether it's on-prem or in the cloud, is the fact that anything we see, and I go back to the log4j, for example, when that first came out, we saw it on our first customer. We were able to develop kind of the first indicator or behavioral signature, as it were, and get that deployed not just for that customer, but all customers immediately got the benefit, whether they were in our cloud, whether they had deployed, on-prem, whether they deployed in a public cloud, or regardless, they got the benefit of it. The other beauty that we had was because we were seeing the attacks across the multitude of different customers we had, as those variants came along, we were able to, continue to test against those variants and then deploy additional capabilities that then each of the customers were able to benefit from. And
Mhm.
so, whether you deploy on-prem or in the cloud, you're getting that kind of, both benefit from kind of the common platform and the common visibility and the crowdsourcing that we're able to provide there. But the next layer up then really gets into our ability to layer on when we host it, things like enterprise grade DDoS. And again, the bot solution is going to be even more effective the further out to the edge that we get. And so we're able to use even more capabilities as it relates to IP challenges, IP interrogation, active deception, certain components that we can provide the further we get out on the edge, and especially when you're talking about our hosted platform. Having said that, I mean, you still get 99% of the capabilities that can be deployed either in an image, whether it's an AMI in AWS or a Google image or an Azure image, or whether again you decide to deploy it deeper into the stack, whether it's your service mesh or whether you decide to take the container and just run the container as a sidecar at the microservice level. So there's flexibility in the deployment, but the beauty of the solution is that it's always ephemeral. It's always pulling the latest and greatest threat intel, and it's always basically providing metadata to our cloud analytics platform where we can see the broader patterns across customers. We can see the broader patterns even across different application environments within a customer, and then utilizing that data to be able to identify the who's are doing it as well as the hows that they're doing it, and then let that basically be shared across all containers, all customers, regardless of the environment that they've been deployed in.
So this question might overlap with some of what you've already had to talk about, but just to make sure that I'm being as broad as possible here. Um, for those who are evaluating different API protection vendors, what are the key capabilities they need to be looking for?
Yeah, and there's some overlap with what we said before, but I think, the things that obviously we think are important, we're obviously a little bit biased, but we've been doing this for a long time. I mean, the API discovery and kind of the risk analysis aspect is a key component, I think, of any solution that you want to have out there. So whether that's the observability of the transactional flows and kind of the, how you're seeing the APIs utilized. I like the schema compliance, whatever you want to call it, but the ability to, provide a specification, whether it's ingested or whether that's kind of created by the platform, but the ability to compare and contrast what you're seeing in the real world versus what your expectations are. the ability to also then, from a catalog or from a discovery component, take that transactional data and highlight the key areas and that you're where you're seeing unexpected results, and then decode that into whether it's a what we would consider to be a potential vulnerability that you should look into, or whether it's just a hey, you got a high risk, and therefore
Hmm.
we need to make sure we have the right policies put in place. So that's kind of the first pillar for me, is all around having the catalog and ideally something that helps you understand the risk of the specific APIs and their endpoints. I think having a solution that's kind of fully integrated, meaning that it's not just an analysis and detection platform, but that it can also provide real-time blocking. Having a solution that doesn't just look at APIs, but looks at attacks in whole and can look at not just the API traffic, but the web traffic, and protect against both, because it's providing the correlations and the detections across both. DDoS protection. Again, not every attacker is going super low and super slow. A lot of the techniques that we're seeing in this day and age are intentionally throwing as much traffic to overwhelm the application and the security services as they can. And so having the ability to, provide DDoS layer level of protection, both at layer 7 as well as layer 3, 4. Bot management is a must, though. I think, again, these attacks in the modern age, they're definitely being distributed. It's so easy to arm your attack vector across some form of bot network that can really leverage kind of that breadth, as well as overwhelm the security solutions as a whole. So I think something that's fully integrated, has kind of the full stack protection, super important. And then we talked a lot about it. I personally, I think it needs to be inline, but regardless, it's got to have kind of this fully contextual view. It can't just look at a single request, make a binary decision. It's got to have the ability to, look at the steps that the attackers are taking, be able to kind of correlate multiple steps and multiple indicators of suspicious behavior back. And then, for us, it's a risk-based blocking model. I mean, if it's an all-out exploitation attempt, we'll block it the first time. But for most of the other things that are out there, you're wanting to pull this information together so that you can really, separate the wheat from the chaff. Who are the legitimate users? Even if they have, small sets of suspicious behavior, they're probably not a high enough risk, level of risk. These guys, though, we've seen enough bad activity. It's time to get the IPs blocked. It's time to get the entity blocked, and then anyone else coming in from a different IP who shares the same fingerprint, we want to get those guys blocked as well. Those are, you know, three legs of the chair, and then I think for us, the fourth leg really comes down to the managed services piece, and it's not just managing the platform, but it's having a set of resources that can assist with everything from making sure the deployments go okay, making sure that when the applications or APIs are released and inevitably they cause some issues, that somebody understands your environment as well as our platform and can assist. More importantly, somebody who's looking for the CVEs or the new vulnerabilities that are coming out and making sure that we're constantly testing our solution. As the 0 days come in, we're creating common protection schemes, and then obviously for each customer, we're creating custom protection schemes. Having a group of resources who are the experts in this particular field, understand not only the solution but also how it gets deployed in the environment, and then God forbid you're under a real attack, can provide that level of support behind the scenes. That's to me, that's almost as critical as the technology itself. And I think as a co-founder of our company, I'd love to tell you that every one of our customers comes back and says, "Oh wow, ThreatX technology is the greatest thing since sliced bread." And that's probably why they bought in the first place. But the reality is, when we get our customer sat surveys back, they always talk about it. Hey, it's working with the ThreatX team. It's working with the ThreatX managed SOC. That's really where they see the value and the potential, because our SOC has the right tools, the right visibility, and can partner with the customers to make sure that they're fully protected. So for me, those are kind of the four legs of the chair that we kind of established our business around. And then the only other thing that I'll say is kind of completes that picture is it needs to be something that's easy to deploy, it gets immediate results, and so that's where kind of leveraging the container based approach has been something for us that allows customers to see immediate results right away and in many cases go into full protection within just a few days. So
So we have one more question from the audience,
okay,
and this actually kind of ties back into a question somebody else had a little bit ago about the cloud-based versus on-prem. But
sure.
the question is whether ThreatX has any customers who use the cloud offering to protect API exposed to the public internet, but then use an on-premises version um, of ThreatX to protect APIs that are only exposed to the internal network.
Yeah, and I would say the answer is yes to that, and yes in general to the hybrid solution, hybrid deployment type of model. So we certainly have some customers who, hey, and a lot of times, I mean, even large customers like this model, but especially mid-sized customers where they may only have a handful of security resources, they love the hosted solution, and they're really most concerned with their edge. And so they may be 100% cloud, but that's a smaller percentage of our customers in this day and age. Most of our customers have applications distributed across multiple cloud environments. They may have multiple CDNs that they're utilizing out in front. They've got multiple API gateways, and so there really isn't just a single size fits all. And
Mm-hmm.
so they, often will try to put as much as they can, especially as this question kind of indicates, of the external traffic through our cloud because it is the easiest, solution and provides a lot of, key capabilities. But then they want to see the east-west traffic, or they have other scenarios where it just makes sense to deploy on-prem. And so that's kind of the flexibility of the architecture. Each of these, typically the way we're going to deploy, even in our environment, but also how we recommend for our customers is, some form of load balancer on the front end, an auto scaling group, and then, depending on the interpretation, they may need a natted gateway or a similar load balancer on the back end. They can still deploy as a sidecar. I mean, again, lots of flexibility in those deployments. But the answer to the question at the 50,000 foot level is absolutely. We have customers that are constantly deploying in a multitude of different deployment options to fit kind of their needs. And east west didn't used to be a huge thing for us. And I would say just in the last probably year or so, we've seen more and more customers coming to us and wanting to deploy on-prem and really cover that internal traffic as well. So absolutely.
Very good. Very good. Good ending spot.
Okay.
So, Bret, this was great. Thank you for your time today.
Thank
And
you.
also a big thank you to ThreatX for sponsoring this webcast. And of course, thanks to everybody who joined us today. And hope you found value in it.
Absolutely. Well, thank you so much, Bill. I really enjoyed it, and yeah, I hope folks got at least a little something out of it. It's a broad topic and one that we could have talked on for many hours, I think. But hopefully, this gave them a good taste at least.
Very good. Well, everyone, have a good rest of the day.